Okay, so question number 8 is figure 1 shows the sketch of a design for a badge. The design consists of a triangle OAB joined to a sector OBC of a circle with center O. In the design we have OB 3.4 centimeters. So if in this sector this is for 3.4, so obviously this also would be 3.4, the radii of the same circle. Then AB is given to be 1.9 centimeter. Angle AOB is given to be pi over 6 radians, and angle OAB is greater than pi by 2. So as not to confuse it with the 90-degree angle, say they clearly told us that this is not a 90-degree angle, this is greater than 90 degree. Okay, so making your method clear, find the size of angle OAB, giving your answer in radians up to 4 significant figures. So in this particular, we will be first considering this triangle OAB, and they have clearly told us that this A and the angle at A is not 90 degree. Okay, so that's fine. So this is not a 90 degree angle, so we have to find this angle. Okay, so let's look into this. Which things do we have? We have two sides and we have one angle, so we can use the law of sines, okay, so as to find the missing side. So if we do by law of sines, we will be having 1.9 over sine of pi by 6 will be equals to 3.4 over sine of A. Okay, OAB or A, angle A. So let's do that. 1.9 over the opposite angle is pi over 6, so sine pi by 6 equals 3.4, and the opposite angle to 3.4 side is sine OAB. Okay, so from here we can get the angle OAB. So sine OAB is equals to 3.4 over 1.9 times sine pi by 6. So solving this all will give you 0.8947. Then sine inverse of this will lead us to angle. It will give you 1.077. Okay, so this is your angle, but there is one thing into this. This is your, like, the whenever you do sine inverse of some angle, you get the angle, the basic angle alpha. So if you make the grid here, so you can clearly see that your angle that you found to be is your this angle. I'll try and show you this, is going to be your this angle alpha. Okay, The angle that you have found just now is this angle alpha, but your original angle that you need to find is this angle. Okay, and this, to find out this angle, you need to do this. This angle is pi minus alpha. Okay, so this is pi minus alpha. So if you are getting this 1.077, this is alpha. So your angle OAB would be angle, as it is in the second quadrant, it would be pi. Actually we don't need the actual angle, we need the angle from this point to this point. Okay, so we need this angle, actually not points, but yeah, just to make you understand, pi minus alpha, and this will lead us to 2.03. Okay, we need to give answer in 4 significant figures, so no worries, let's do that. Okay, so when I recalculated it directly, there is a little difference in the values, so the correct value would be 1.1078 for alpha, for the sine inverse of this value. And so skip this step. Okay, don't write this and then do sine inverse, directly do sine inverse of this whole value, so it will give you more accurate answer. Okay, so not to do this and directly do the step, so it will give you 1.1078. then when we will be doing pi minus alpha, it leads us to 2.0337. so what we can do is, we need up to 4 significant figures rounded off, so it will become 2.034. Yeah, that's your final answer for part A. Now now part B. Part B says find the area of the triangle OAB in centimeters square, giving your answer up to 3 significant figures. So now we need to find the area of this triangle. So area of triangle is, do we have half base times height? No. Yes, we have. We also don't have base. Okay, so no perpendicular distance, no height, so we can use the sine rule for area. Do we have any 2 sides and the included angle? If we do have these 2 sides, so if we find this third angle, because we know the rest of the 2 angles, then we would be able to find out the area of this triangle. Okay, so let's first look into this angle. So your angle B would be pi, because the sum would be 180 or pi, minus pi by 6 minus pi minus alpha, that is 2.034. so this angle is actually 2.034 in radians, so pi minus pi by 6 minus 2.034. okay, so this is going to give you the angle so this gives us to 0.5839. okay, now we can apply law of sines for part B, using sine rule for area of triangle. For area of triangle, so area is half 2 sides. What are the 2 sides? OB and AB, OBAB times sine sine of your angle. So which one is the sine of angle? Yeah, 0 point sine of 0 angle B, OBA. Okay, so now I'll put in the values. Your values are 1.9, 3.4, sine of 0.5839, half of this. So I took this all. If I could take this down, it would be more helpful, because each time we have to look it back above. So first we have found the angle B from here. So this is it, and then this one. So arranging it a bit, and yes, this is your, okay. So we will, the final answer for our area will be 1.7808. So they told us to find the answer up to 3 significant figures, so it would be 1.78 centimeter square. Okay, now let's move on to the part C. Part C says, given that the ratio of area of the sector to the area of triangle is 3:2, show that the angle BOC is 0.462 radians to 3 significant figures. So they are now for asking you to find BOC, this angle, third angle. We need to find out this third angle. Okay, given that the area of sector to the area of triangle is 3:2. So part C says, area of sector to area of triangle is 3:2. So that means the ratio is equals to 3/2. Okay, if you want to write, you can write the names OCB and OAB. Okay, the formula for area of sector is half r square theta. Area of triangle OAB we already found to be 1.78. Okay, so this is equals to 3/2. Okay, so what do we know in the area thing? We know the radius r is 3.4. we need to just find the theta. So 3.4 square theta, so half 3.4 square theta over 1.78 equals 3/2. So solving this for theta, we will get theta to be equals to after cross multiplication and solving it 0.462. Okay, now go further for part D. Part D says 462. Yeah, we got the same. Okay, now hence find the perimeter of the badge in centimeter to the nearest integer. Perimeter. Okay, we need to find the perimeter. Perimeter would be if I show more precisely, how could we be having our perimeter, this length, the outer boundary is the arc length. Okay, this arc length, this AB, this OA. Yeah, so perimeter would be OC plus BC arc, arc BC plus BA plus AO or OA. Okay, so what do we know out of these? We know OC to be 3.4. We need to find arc length. AB is already known. Okay, let's write it AB more conveniently. And OA is the third side that we also need to find. So first find arc length BC. Arc length BC, you know the formula for arc length, r theta. R we know to be 3.4 and theta we just found in the last part, 0.462. So use that, 0.462. It will give you 1.5713. Okay, now last thing we need is AB, length AB. As you can see, OA. AB is known. We need to find OA. That is unknown. So OA is the third side of your triangle. We know the two sides and the included angle. So we can apply the law of cosines, or you can also use law of sines, because you know you have the angles and you have the sides. So you can use that. But let's do it by using law of cosines. OA. For OA, by law of cosines, OA square is equals to OB square plus AB square minus 2 times OB AB cos of, what is the opposite to OA? Cos of angle OBA. Angle B. Okay, so let's substitute in the values. What is OB? 3.4 square plus 1.9 square minus 2 times 3.4 times 1.9 cos of angle B. We haven't written the angle B yet here. Angle B we found to be 0.5839. So let's solve it. So this is OA square, but when you will square root it, OA will be equals to 2.0953. So let's get into this. Let's write whatever these dimensions are. So dimensions would be OC 3.4 plus arc length BC is 1.5713 plus AB length is 1.9 plus OA that we've just found to be 2.0953. So perimeter will give you, after add, 8.9666. Okay, so have they mentioned up to how many significant figures? To the nearest integer. Okay, so that's very simple, so we'll just round it off to nearest integer 9. Okay, so this is your whole working for your question 8. Okay, that's all about question number 8. I hope you understand this whole. Thank you.